We have a Krank Rev Jr. Wanted to document the scope of the work because it was a lot. And anybody dealing with this is going to need to know a few tricks. And yeah, let's get into it. So you can tell just by the way the chassis and transformers look. This, I think it's from coastal Texas, so the ocean's over there. A lot of corrosion in this one. Had to replace all the potentiometers. Deoxit did not fix it. They were so bad it was literally cutting signal out completely. So they were some kind of weird pots. So went with solder lug and wiring. They are built with Wyma film caps, which are actually good quality. Recapped all the electrolytics. The rear power board is the main issue. To get it out, for the first time, you have to desolder the output tube sockets. There's an interference fit. It's like they were soldered in place during production. It's one of those amps that's probably easy to build and extremely difficult to maintenance as far as what it is. You would hope that these small boards would just pop out quickly, but they don't. The original jacks were all extremely corroded. So it has brand new jacks everywhere because they're switch contacts and those need to work. I actually did a full restoration on this and then it came back because whenever, due to vibration, it was having a loud crackling noise. And so just chopsticking this cable especially and just tapping the board, that extremely loud signal cutting out crackling noise was occurring. So let me show you everything I did to this rear board. One of the main problems that I assume is going to be on every single one of these is this looks like R13 resistor. It's this style that's touching off against the board, and so apparently this one gets very hot and it cooks the board brown, and so we don't want that to become conductive. So I replaced that. I actually paralleled a couple of $500 to get 250. So it was probably the cathode resistor. It's been a long time since I've done that, about half a year ago. So I think this is partially cathode biased. I do remember it's running at a much lower voltage than a lot of 6L6 GC amps. And you can pretty much pop. I think they run 5881 WXTs, the Sovtex on these. So anyway, replace that with some sort of non-standing resistors and give it airspace. And I actually put a dab of epoxy to the fuse holder so that it's mechanically strong. Like I said, recapped the electrolytics. There's another one. And then I had to rebuild a lot of stuff around the phase inverter. The trace and solder pad was completely shot, so I had to run bus wire here, and then it extends underneath the board to somewhere over here. I should have took a picture, but I didn't. Replace the screen resistors. They had drifted. The other one's there. There's another electrolytic. I had to rebuild some traces, but this connection here from the preamp board to the power amp board, chopsticking that was extremely noisy. And it used to be these Molex headers. So that cable had this, male Molex header on it, and then there's the female. So I removed that from the board, clipped that off, stripped it, and hardwired it. These got real corroded. So rather than try to re-terminate the same faulty you know, crappy Molex header, you know, and just hardwired it. And this is the pinout of those wires. So see that the inner two connectors are connected anyway, and it's really just one black wire running to it. And then the outside ones are actually connected on the board, this white and red wire there. Yeah. I was afraid, and I'm pretty sure that tapping the board, it's possible that the contacts inside the impedance selector switch were corroded. So I ordered new switches from Mauser. This was the closest thing. There's the part number. GG-350-0020 is what they had on stock. DPDT slide switch, this CW Industries brand. But the difference is the original had this kind of long, not bat, but long slider, and the new ones came with a short. So I went ahead and replaced. This is the voltage selector for US versus Europe. So I went ahead and replaced that one too, even though we're leaving it at 120 volts. But I left the short slider in there, so you can't mistake it from the front of the amp for the impedance selector. So if you're standing at the front of the amp and reaching to the back, you won't accidentally change the voltage. You know, so I thought that was actually a good move, was going with the shorter replacement. And then I deconstructed one of the switches, and you can see how corroded those contacts were. It may not show up great on camera because I have a lot of light on it, but yeah, one of them was real black. One of the central ones was totally corroded gray, and then the other side, which I think it doesn't even matter. I think it's just a lift going to the 16 ohm side. Anyway, one of the sides, I don't even know that is actually switching traces or not. But yeah, so it was a good move to replace that switch due to the corrosion anyway, because that switch does get used sometimes, as opposed to the voltage switch. You know, over here that should never change, but the 816 impedance selector, you know, it's really risky if that's not making good contact, or if the vibration from the speaker cab or whatever is kind of making that intermittent. You know, you're risking possibly a tubes or output transformer or anything else. So you want that connection to be really good. I thought about just hardwiring it to 8 ohms or whatever his cabinet was, but he expressed a desire to leave that as stock functionality. So yeah, I rebuilt the switch, and I used one of the long sliders during the rebuild. That's all I switched over. It has these little rocker pieces in there. So these are the old ones. See, they're pretty dirty. Sorry for the focus. There you go. So I left brand new everything except I just swapped over one of the long sliders. Yeah. So, and then here is the trick that you really should know. Because of the interference of this phase inverter tube socket against the stock chassis drilling, something I discovered was I used a dual fluted step drill to open up that hole. And yes, it does have a gap now, but I mean, even the factory output tube sockets have a little gap to where whatever dust or anything could kind of get in there, I suppose. But whenever I opened up that hole, well, now I could solder those output tube sockets back to the PCB and install the PCB. It was still a pain in the ass, and I kind of had to use a flathead screwdriver, and because the board angles in like that at first, you know, you can't just drop it down in there and stick it in flat. You're angling it in, and then you're not really getting good clearance at the rear of these output tube sockets. So I just took like a flathead screwdriver and kind of forced it in there, and it dropped in. after I opened up the hole for the preamp tube socket. When that was still stock, it was too tight of a clearance on that hole to allow these tube sockets to be reinstalled with the PCB. In other words, you would install the PCB and then from the bottom put the tube sockets back in and solder them in. But after doing one rework of this, after the initial repair, these solder pads are so fragile and such a thin material that, you know, they began getting damaged. I mean, I'm consider myself to be highly skilled at desoldering and rework, and yeah, it's just not a super high quality board, you know, and so yeah, some of them get damaged, the eyelets there, and so now I should not have to rework those. Now if I had to take it apart again, because I opened up that hole, I should be able to flex it out and get it out. It takes a little force, unfortunately, but I've replaced so much on this, totally rebuilt all the power distribution stuff, all brand new jacks, new switches, new phase inverter components, new screen resistors. I mean, I've done like everything to this board, maintenance-wise, standard maintenance-wise. So this should not have to come back out for a long time. So anyway, that's kind of the tricks of this thing. This board is much easier to get out. There is clearance. You know, again, it did flex up to get it out and everything, but it was pretty easy to get that board out. You know, marked the numbers like I7, write a 7 on there with good permanent Sharpie. You know, I mean, you could tag it with tape, but God, it takes a long time. Just like working on fenders or anything, just write it on the quick connect there. So yeah, that's all I can think of. But yeah, I actually had a lot of time in this, way more than you would expect for such a small kind of lunchbox size amp that seems to have a lot of area in there to get boards out. Getting this power board out was, it was painful, and reworking it was painful. So one other thing is you have to, it's better to anyway, desolder this ground wire from the IEC receptacle when you're going to take this board out. You disconnect everything, and that's the one wire that would still be holding it together. So just desolder that, you know, and then when you finish putting it back together, you just resolder, of course. So yeah, I'll be doing sound check soon, and that'll be that. It should be good to go.